ionization of water. This is where we finally get into this idea of pH, which we haven't even mentioned yet. Alright, so we're going to talk a little bit about pH in the next couple sections as we're building toward this idea. So water all by itself does what's called auto-ionization. In other words, water can be an acid or base because it's amphoteric. So in this case we have the acid. In this case we have the base. Alright, so we form H3O plus and hydroxide. But notice it's a 1-to-1 ratio. So the hydronium ions to the hydroxide ions are 1-to-1. We can set up an equilibrium expression, in this case Kw, where W stands for water. There's hydronium ion, there's hydroxide ion. Okay, and at 25 degrees Celsius, so remember K is temperature dependent, so at 25 degrees Celsius, hydronium and hydroxide are equal to each other. They're always equal to each other. And then, as it turns out, each one of those concentrations at 25 degrees Celsius is 1 times 10 to the negative 17th. So when I plug that into my Kw, I'm just going to write H plus. Here's for water. 1 times 10 to the negative 7th. Did I say 17th? 1 times 10 to the negative 7th. 1 times 10 to the negative 7th. Right. When I multiply those, I get 1 times 10 to the negative 14th, which is the value for Kw at 25 degrees Celsius, which really 25 degrees Celsius is room temperature. Most of our acid-base reactions we carry out are at room temperature. Okay? Now, whether a solution is neutral, acidic, or basic is determined by the ratio of hydronium ion to hydroxide ion. If they are equal, so if the hydronium ion and the hydroxide ion are equal, the solution is said to be neutral. If we have more hydronium ion than hydroxide ion, the solution is acidic. And if we have more hydroxide ion than hydronium ion, the solution is basic. Okay, so just now we're introducing this idea of acidic, basic, and neutral, and now you know what determines whether the solution is acidic, basic, or neutral. But what's important here is even an acidic solution is going to have some hydroxide in it because it has water. Right? So even if it's just pure HCl aqueous, that aqueous means it's dissolved in water, and so it's going to have some hydroxide in there. So here, same thing that we're just looking at. So one thing to remember, at 25 degrees Celsius, this is always true. And so we'll see how we use that whenever we start calculating pH. Oh no. So here you can see how it's set up. If we have a neutral solution, the concentrations are equal to each other. If we have an acidic solution, the hydronium ion is greater than the hydroxide. Acidic, hydronium ion greater than the hydroxide. But notice, when I multiply these values together, I'm always going to get 1 times 10 to the negative 14th. Right? Basic, then the hydroxide is going to be greater than the hydrogen ion. But again, when I multiply these together, I'm always going to get 1 times 10 to the negative 14th. And that leads us into this idea of pH, which we'll talk about in the next video.